So the first step in design process is recognizing the need, and second step in design process is the problem definition, right? So recognizing need is something which we already saw, and now the second step is problem definition. So once you clearly know what is the need for it, yeah, now you should also think about problem definition, yeah, which is more specific, yeah, than recognizing the need. So need is just a necessity, and definition is what are you going to achieve. Okay, so clearly understand, need is just the necessity, but the problem definition, it's where the requirement comes to life. You're going to define the problem. What are the problem you are having? Yeah? Say for example, okay, if there is a need for a cleaner air, so this is a need, right? This is a need or necessity. So this is a need or necessity. Now the problem definition or a problem would be that, due to the dust from a power plant, or it could be an automotive exhaust. Now let's say an example that a city is reeling under pollution. Yeah, now there is a need or necessity to have a clean air there. Now for having this clean air, okay, you could have n number of possibilities. Okay, say for example it could be your automotive exhaust, okay, or it could be your manufacturing emission, yeah, or it could be some power plant emission, yeah, so on and so forth. Yeah, so the important thing here is that you need to understand what are the problems which is causing this, or what are the various scenarios which is causing the problem. Yeah, so for a problem definition, the problem should be clear and concise with adequate technical specification. This is very important. Okay, so this is a process of converting a normal layman requirements or a normal need or a necessity into a technical requirement. So you have to be clear, concise and precise on the requirements or the problem definition. Okay, you have to be clear on the problem definition, mainly because this is going to set direction for the project. Okay, and anything that the designer's freedom of choice is a specification. Okay, so say for example anything that limits the designer's thought process is a specification. Okay, for example, you are designing a table. Yeah, let's assume a simple example, or you are designing a cycle. Okay, maybe the height of the cycle may be a specification. Okay, there is a need there is a need to create a cycle which incurs less amount of power or less amount of effort from the rider, for an example. Now this will also have certain specification, because the designer can't make it so big, the designer can't make it so small. He has to make it at the optimum level of the requirements. So at this point of time, in terms of volume or in terms of size, the designer's freedom is being limited. So it's a specification. Okay, so anything that limits your freedom of thought process in a design is a specification. Okay, so the formal problem definition, it should include the goals and objectives. Okay, what are the goals and objectives? Okay, what is must, what is must not, what is want, what is don't want. So all these things are very important criteria to evaluate the design. Okay, so the problem definition should be very clear to mention what it has to include, what it should not include, what is must and what is not must. Okay, so let's take an example of a problem definition. Okay, now there is a need to design a robot which can maneuver in both outdoor and indoor environment. So this is a need. This is a need. Stage 1 or a necessity. You have to design a robot. Now the problem definition is the robot must be capable of carrying a payload of 50 kg. Yeah, we are more specific. We are more clear and concise here. The robot, okay, has to carry 50 kg. Okay, the need is that you have to design a robot which can maneuver in both indoor and outdoor environment. Say it is delivering certain packages. Let's take an example of any a delivery organization which wants to create a robot. Yeah, now they have a requirement that the maximum load what the robot can carry is 50 kg. Okay, and then they climb high stairs, yeah, up to 2 kilometers per hour. Okay, so here I am more specific in terms of what is the quantity of the height of the, or what is the height of the stair, and at what speed the robot is going to climb. Okay, and pick the load and deliver at the end location. So it's a robot which is going to take the product from point A to point B. It is going to drop it, pick the luggage from point A and drop it to point B. So this is also one of the problem definition. Again, you cross obstacles up to certain height. Okay, because it also will come across a lot of obstacles as it moves from point A to point B. Okay, now this robot has to cross this obstacle. Okay, and climb a slope of, this is 30 degrees, say for example. Okay, climb an example of 30 degree or whatever slope angle it is. Okay, so this is very clear in terms of how much angle the robot has to walk or climb, whatever it is. Travel in any direction including sidewalk. So the robot not only can move in this direction, okay, it can also move in this direction, sidewalk. So sidewalk is nothing but walking in the side. Okay, so the robot can also maneuver easily for a sidewalk. Carry out any delivery activity within 5 hours of continuous usage. So it's very clear. I've given the usage is 5 hours. So whatever mode the robot is powered, if it's a battery or whatever it is, yeah, the robot has to carry out the task for 5 hours. So we need to ensure there is a sufficient power for the robot to carry out the task for 5 hours. It's very clear. Okay, so navigate in complex environment with pets, pedestrians, vehicles around. Okay, so it's a normal city conditions where you see a lot of people working, walking with you, a lot of pedestrians and a lot of vehicles, and then you will have to cross the roads or climb the bridge, so on and so forth. So this robot is nothing but replacing a delivery person's task. Yeah, say example, you are replacing a mundane task from one place to another place, or you are trying to automate certain delivery of parcels from one place to another place. So this robot will do a job of a regular human being, and these are the problem definition. So if you see, the need is very simple. The need is just one line, right? But the problem definition is very elaborate or concrete. It's very clear. So please make sure whenever your need is clear, you get on to the next step of problem definition, which has to be clear and concise. Okay, write down all the specifications of the requirements. This is very important. You may have to have some customer interviews to understand what are the customer requirements. So you need to, through the interviews, you can kind of collect the data, or through requirement engineering discussions, you collect the technical specification data, and also few implied data from your stakeholders, or the requirements from the stakeholders. So these information has to get on to the product as a problem definition. Okay, so first we saw the recognizing the need, and second we touched upon the problem definition. Okay.